Proxima B has been a hot topic ever since astronomers figured out that the planet lies in somewhat of a Goldilocks zone of the system. Just like our Earth, Proxima B is situated in a space that's not too hot and not too cold for life to exist. Scientists have now found something strange flickering in the night sky, and the source is Proxima B. These weird anomalous lights have gotten the greatest minds across the globe scratching their heads. So, what can they be? And does this mean there's life on our neighboring world? One of the more interesting goals of the James Webb telescope is to search for exoplanets, where one day we could find evidence of life beyond our own planet. That's not as easy as it sounds. Finding another Earth-like planet might be more complicated than you think. New observations suggest that the closest alien planet to our solar system is even more Earth-like than scientists had thought. In a study, a team of researchers found that the lowest possible mass for Proxima B, which is just 4.2 light-years from Earth, is 17% more than our planet. Scientists thought that the exoplanet, which lies in the star's habitable zone, was 1.3 Earth mass large. The new measurement shows that Proxima B might be more like our home planet than previous observations led scientists to think. Researchers used the Echelle spectrograph for rocky exoplanet and stable spectroscopic observations, or ESPRESSO, to study Proxima B. ESPRESSO is a spectrograph that is currently mounted on the European Southern Observatory's Very Large Telescope in Chile. Remind me to get a coffee after this. Anyway, with spectrographs, researchers can examine an object in closer detail by studying the light coming from it in the wavelength that makes it up. 4 years ago, scientists found the exoplanet with an older spectrograph, HARPS, or High Accuracy Radial Velocity Planet Searcher, which is at ESO's La Silla Observatory in Chile. With these new observations, they have a more updated, ultra-precise view of the planet. Michel Mayer, a Swiss astrophysicist who won the Nobel Prize for Physics in 2019 and helped to develop a new type of spectrograph called ELODI, said in the same statement, "ESPRESSO has made it possible to measure the mass of the planet with a precision of over 1/10 of the mass of Earth. It's completely unheard of." The study's co-author, Francesco Pepe, an astronomy professor at the University of Geneva in Switzerland, and the person in charge of ESPRESSO, said in a statement, "We were already very happy with the performance of HARPS, which has been responsible for discovering hundreds of exoplanets over the last 17 years. We're really pleased that ESPRESSO can produce even better measurements, and it's gratifying and a just reward for the teamwork lasting nearly 10 years. Okay, so what's so special about this planet? Well, Alejandro Suarez Mascareño, the lead author on this study, says Proxima B is one of the most interesting planets known in the solar neighborhood. This alien world orbits Proxima Centauri, which is a very similar star to our Sun. Liquid water could be found on the planet because it is in the middle of its star's habitable zone, and where there's water, there's a potential for life. Scientists think along with liquid water, there's a chance Proxima B also could be a rocky terrestrial planet like Earth. So far, Proxima B has all the right qualities. Proxima B is a planet that orbits a star that is similar to our Sun but is much smaller and less bright. Researchers think that the exoplanet is tidally locked to its star, which means that one side is always facing the star and one side is always facing away. This makes the planet light on one side and dark on the other. Currently, it's unclear if Proxima B has an atmosphere. The planet is very close to its star and completes one round around it in 11 Earth days. Basically, each year on Proxima B is 11 days. If you were 25 years old on Earth, you'd be about 830 years old on Proxima B. That's like having a birthday every other weekend. Some researchers think that the radiation from Proxima Centauri may have stripped away the air on the alien planet, making it impossible for it to hold on to liquid water, which would technically mean that the planet isn't all that habitable. In that case, it would probably be hospitable for humans. We're not too sure about that one, but we do know that many factors affect a planet's habitability, such as temperature, composition of the planet and atmosphere, water or lack of, and radiation from its sun. Christoph Lovis from the University of Geneva says, "The confirmation of Proxima Centauri b, now the nearest confirmed exoworld, is exciting. Its potential habitability and proximity to our own solar system gives us something to think about. It's another big step towards finding an inhabited world beyond Earth." The exoplanet's host star is a red dwarf. For those unaware, a red dwarf is the smallest and coolest form of star and are by far the most common type of star in the Milky Way. But because of their low luminosity, individual red dwarfs cannot be easily observed. Red dwarfs like Proxima Centauri are known to emit flares, and these flares make habitability for red dwarf exoplanets even more complex and interesting. On the other hand, red dwarf stars are very energetic and could strip the atmospheres off of planets that are too close. Whether this is the case for Proxima Centauri b is not known yet. If it still has a thick atmosphere, it would be a good place for other telescopes to look for signs of life, such as chemical signatures. Here's where it gets really interesting. A signal was found in late 2020 coming from Proxima Centauri, the star that is nearest to us. The signal, known as BLC-1, is still being examined to make sure it isn't just an echo of our own civilization, as they generally turn out to be. So why don't we simply examine the planets in Proxima Centauri to determine if there is civilization there? The radiance from our planet's night side is the most evident indicator that someone lives there from space. Light emitted by our cities is lost into space. The issue is that the telescopes of today's generation lack the power to detect light on other solar systems. However, a number of scientists are already evaluating the capabilities of the already conceptualized next generation of telescopes. What conclusions were drawn? If we were technologically developed enough or glowy enough, we might be able to tell if Proxima Centauri is home to another civilization. Eliza Tabor of Stanford University and Avi Loeb of Harvard point out that a tidally locked planet with a permanent night side would need artificial lighting to support a technological culture. Coincident for civilizations depending around neighboring stars are pretty unlikely, making this one the longest of long shots. On the other hand, a civilization arising elsewhere could be detectable through its artifacts on the worlds it has chosen to study. Last year, researchers Eliza Tabor and Avi Loeb tested out the Webb's ability to hunt for alien lights, but since it wasn't in optimal functionality then, the results were a bit rough. The virtual JWST was trained on Proxima B, the one confirmed planet in the Proxima Centauri system that could presumably host a civilization. Tabor and Loeb measured the amount of artificial light compared to the amount of sunlight that hit the day side of the planet. 0% on this scale would assume that the night side of the planet is completely dark. 100% means the night side of the planet is as equally bright as the day side, which also isn't a possibility. The type of light used by the hypothetical civilization on Proxima B is thought to be similar to LEDs on Earth. If the artificial night side illumination of Proxima B reaches 5% of the natural dayside illumination, the Webb could detect the artificial light with 85% certainty. If artificial illumination were to reach 9%, Webb's detection rate would rise to 95%. Now, 5% illumination doesn't sound like much, but we are talking about the light from a star. As weak as Proxima Centauri is compared to our Sun, which is about 20,000 times dimmer, that's almost like putting a firefly next to stadium lights. By comparison, Earth's artificial illumination is only 0.001% of reflected stellar illumination. In other words, the Webb would not be able to detect a civilization on Proxima B that is as lit up as ours. The brightness of those lights would have to be 500 times greater. That scenario is imaginable. As we've previously reported, Proxima B's orbit is so near to that of its host star that it may be tidally locked, with one side of the planet always facing the star and the other experiencing eternal night. The light infrastructure of a civilization on a tidally locked planet will likely require special attention, and it may be possible to utilize very powerful orbital mirrors to reflect sunlight onto the planet's night side so that it may be observed by our telescopes. Of course, this is just a theory. While we're still not sure what Proxima Centauri b is actually like, just the fact that it exists around the nearest star to our solar system supports previous research showing that Earth-sized and super-Earth-sized exoplanets are common in our galaxy. What we should be excited about is that researchers have confirmed the existence of an Earth-sized exoplanet orbiting the nearest star to our Sun, Proxima Centauri. It's final. As scientists continue to study this system with new and better technology, we will be able to better understand what it's really like on Proxima B. What do you think? Is there life on Proxima B? Or what else will we find there? Let us know in the comments below. And as always, thanks for watching Space Traveler.